y también le doy un cordial saludo a las 201 personas que están conectadas hasta este momento por la plataforma virtual. Ingeniero David, ACIEM, Asociación Colombiana de Ingenieros, es órgano consultor del gobierno nacional desde el año 1971. Hoy, más o menos, somos 14.000 profesionales en las áreas de ingeniería eléctrica, mecánica, electrónica, mecatrónica y demás, e ingenieros civiles. Ok. Nosotros estamos interesados en trabajar en políticas públicas y para el efecto tenemos 10 comisiones de estudio. Las voy a describir para que tengan en la mente la capacidad de pensamiento que tenemos. La primera, reglamento técnico de construcción. Segundo, telecomunicaciones. Televisión. Promoción y desarrollo profesional. Electrónica. Ética. Energía. Formación e integración en ingeniería. Mantenimiento y gestión de activos. Y infraestructura de transporte. Que yo, Jairo Alberto Espejo Molano, soy el director de la comisión desde hace unos buenos años. Sí, ya lo dije. Ok. Entonces, sin más preámbulos, le vamos a dar la palabra al ingeniero David para que inicie su presentación, pero voy a tomarme 2 minutos para presentarlo. El ingeniero David Hao Wan actualmente es el vicepresidente de ingeniería en el proyecto Metro Línea 1 Bogotá. El ingeniero David se graduó en la Universidad de Hohai en Nanjing, China. Entonces, por lo que investigué, la Universidad de Hohai es una universidad pública de investigación que se destaca en las ramas de la ingeniería civil y de transporte, en hidrología, recursos hidráulicos, ingeniería hidráulica, ingeniería de costas, ingeniería marina, y fue fundada en 1915. La ciudad donde está la universidad, Nanking o Nanjing, es la segunda después de Shanghái al sur de China y es una ciudad que tiene más o menos 8 millones de habitantes. O sea que más o menos es como Bogotá. La universidad donde estudió el ingeniero David, más o menos son 30.000 estudiantes, es como similar más o menos a nuestra Universidad Nacional de Colombia, de Bogotá. El ingeniero David ha tenido la oportunidad de trabajar en muchos países del mundo. como por ejemplo, Neymar, Macao, Ghana, Canadá, UK, Sri Lanka y aterrizó en Colombia. Welcome to my country. El ingeniero David ha tenido la oportunidad en todos estos países de trabajar en grandes proyectos. Proyectos que tienen unas inversiones entre 100 millones de dólares hasta 5.000 millones de dólares. Big projects. Y el ingeniero David ha tenido la oportunidad de estar en varios proyectos importantes que se han destacado por grandes premios que le han dado. Por ejemplo, la fase 2 del International Cointer Terminal en China en 1999, donde fue reconocido el proyecto Blue Ban Award. Otro proyecto donde obtuvo un premio es la fase 3 de la misma terminal internacional de containers en China, 2006. Y antes de venir a Colombia, en el 2020, en Sri Lanka, tuve la oportunidad de participar en el Airport Project of 2020 for Port City en Colombia, donde tuve el premio NR Award. Ustedes saben, con esto que acabo de leer, la gran experiencia del ingeniero David, que muy amablemente nos va a presentar una conferencia que tiene una duración aproximadamente de 1 hora. Después vamos a tener una sesión de preguntas de unos 10 o 15 minutos, única y exclusivamente con el tema que va a tratar él. Cualquiera de los interesados presentes o virtuales que quiera hacer alguna pregunta sobre el proyecto Metro, lo puede hacer a un correo que les vamos a indicar y ellos en su oficina de comunicaciones responderán esas preguntas. Entonces les pido el favor que tengan eso presente, que las preguntas solamente tienen que versar con el tema que nos va a disertar el ingeniero David. Ingeniero David, start to presentation, please. Thank you very much.
Un segundo, por favor, mientras Miguel da una pequeña alocución a los miembros que están en este momento conectados en la virtualidad, que también les doy la bienvenida, así que adelante, Miguel.
Ok, muchas gracias, Mauricio. Buenas tardes para todos. A los señores participantes que están conectados a través de la sesión Zoom, ahora que vamos a iniciar en la traducción, por favor, en la parte inferior de sus pantallas van a encontrar un botoncito como un mapa mundi, un globo terráqueo. Allí pueden seleccionar los dos canales. Está el de inglés, que es el sonido original desde el auditorio, y está el de español, que es la traducción al español, valga la redundancia. Entonces, ingenieros, con estas pequeñas indicaciones para que tengan pendiente el cambio del canal en el momento que lo deseen. Muchas gracias.
All right, so good evening, everyone. So it's my pleasure sitting here and talk about some new technologies in the engineering. Is this speed okay for the translator? Yes, thank you. Yeah. Okay. So I'm from China Harbor now. We have we're working in Bogota for the project. Also, I bring some of my colleagues to this opportunity. Okay, they're all from our technical team. Is Laura from BIM, is BIM engineer. Simon is also the BIM manager. So they will help me on some questions in this presentation. All right, so let's start. So today I think is for the engineering discussion. So it's not quite formal. So we can have any question and answer if you have anything. Just raise your hand or interrupt me, and no problem. Today I would like to share some information, the experiences for the BIM practice in the design and the international standard element. Okay, so we go next one. Yeah, I think I don't know, but no, over there you have to come the remote control. Go to that. Not, yeah, the next one. Yeah, that's about me. That's introduced, mentioned by Harold. So I don't want to repeat. All right. So I'll take roughly 1 hour to finish this this presentation. I would share the information from the 7 angles. So from the BIM to the BIM technology and application, and some experiences from me. Okay. So let's from the BIM background. So next one. So the BIM, I believe everybody or here or the audience online, most of you guys knows the BIM is the BIM building information modeling. So this at the moment was widely used in large scale engineering project. From my understanding, so this is 3 wording here: building, information, and modeling. So we used to maybe 10 years ago, we used to work or focus on the modeling instead of others. But this technology is decentralized on the information. So that's the big differences. That's the improvement or the advantage of these technologies. Next one, please. So that's the brief of the history of the BIM development. Is this concept was coming out from the 1970s. It's quite preliminary, and gradually they changed, developed by different changing the name and the concept and the content up to 2001. So the name is fixed as the BIM. So you can see on the right hand side, you can see from the CAD, it is a computer aided design tools through different passes, multiple passes, the peoples or technologies, and finally we got the BIM technologies. Nowadays is well known, and all the developers and the project and come with this. Okay. So when I talk about BIM, so we cannot avoid talk about the level of the BIM. So here we start from the level 0, 1, 2, 3. That's the common use from the modern engineering design stage. Okay. So level 0 is quite a classic way. It's just 2D drafting, and the level 1 we come into the 3D model and 2D drafting and the production from the produced from the 3D model. And level 2 we started consider all the models. We need to build a common database for all the models. And level 3, so we create an open data environment for crossing the disciplines, and by that, so that's the three levels for the BIM. So next slide, we're gonna show the full pictures. So from the 1D to 6D. So that's the for now. So most of the design stage we stop. We up to the 3D, the level 3. And from level 4, and actually we have level 7 at the end. From level 4 up to level 7 is for the construction and the maintenance, the operation maintenance, and the project management. Okay, here is an example. I don't know whether you guys can. It's showing clear. Okay, there's an example for the BIM execution requirement. So we normally, when we get a project, or especially for the large scale project, we'll apply. We're planning the project in the BIM line with the planning stage, design stage, construction, and operation. There's the full. It's the full life cycle. So I just want to show you that BIM applications in over the life cycles. Okay, for the so at the moment, so we have the international standard, and for this kind of a project, during the planning stage, we have to start to know what's the requirement or the needs from the operator, because the BIM, like I said, the information is the key, is the core for this technology. So the information has to start from the planning stage through the design stage, construction stage, operation, and finally handed to the operator. So the information has to be all the way through. So we have to plan at a very early stage for the terminal requirement, that the user's requirement. The user is the operator. Okay, so you can see this. Okay, sorry. You can see the different. Okay, you can see the bar. Okay, some applications from the plan stage all the way through the operation stage. Okay, so like the modeling, like the cost and the quantity, and sometimes for the coordinations, and for some like the property codings. So this will be all the way from the planning to the operation, and some are just for the single stage, but it will be. It's not.
Es mejor de esta manera. No, lo que pasa es que no alcanza a enfocar tan bien, es por eso. Y si apagamos, le quitamos la luz.
No puede ver. Sí.
No, they were saying that you would like that we turn off the lights.
Okay. Yeah. Okay. So next one. So this one is a little bit details for the arrangement from the design, construction up to the operation and the maintenance. So the demand from the operational team shall be highlighted in the design construction stage, such as the information and the LOD and asset coding. That's quite important, because that coding is like the ID for everybody. So the coding for in BIM, like the ID for the every single element from the beginning. So when one element was created, they should be allocated code. This code will be permanent with this element, no matter is a pile, is a beam, is a column, or the mechanical equipment. Okay, so this kind of asset ID is quite important, has to be agreed from the early stage between the designer and the operator. So otherwise, so the designer will have their understanding in the asset management. Sometimes the operator comes to the picture a little bit late for the project. So we had some experiences when the operator come late, they have their own system, their own procedures to manage the assets. So maybe this is totally different from the designer's understanding. So there will be a disaster because at that moment, all the design almost done and maybe the construction started. So all the information attached to the model. So if we want to rewrite this model by the new code, this would be a lot of works and maybe created more errors, mistake. So that's why I want to highlight it. The coding in the BIM technology is quite important at the design stage. We have to, as the experienced designer, they have to grab all this requirement before carry out the design works or the model. Okay, this is a general sketch for the BIM organizations. So just an example for the like a PPP project, we have a concessionaire, we have leading designers, we have some design subcontractors, and also the project management team, and also the delivery team, and also the downward executive levels, the disciplines. So you can see that this the sketch with the different circles. So will be centralized with the concessionaires, and also the designer is quite critical at the design stage. So and we go outer is the subcontractors and also the management team and the delivery team. So that's the position of every different roles in the project in the BIM organizations. So that the concessionaire's requirement is the quite most important. On the right hand side, this is the responsibility matrix. There will be in detail specified the responsibility of different roles in certain single actions. So that's we can share the information with you. After that, it's a little smaller to see. So normally we summarize with the BIM execution challenge for some large scale project, because all these works or actions, we have to consider the information. How to make sure the information flowing down, flowing up, without any problem, without any misunderstanding. So, and also that the information will be added more values by different the requirement by different parties. So here we list up 5 key points. First of all is coordination, because for the large scale project, we have multi-disciplines. Every single disciplines, they have their own design standards, but the coordination between the disciplines is quite important. This is a fundamental guarantees for the BIM model. When we created the BIM model, all the discipline has to be talk to each other every day. So to make sure all the models are perfectly matched to each other. The secondly about the communication. So this communication will be it's different from the coordination. This communication sometimes would be from the client, from third party, from the suppliers. So that's communication from outside, from external, also has to be pay more attention, because that external resource demand also is the input to the designs. And the other one is the technical challenge. Sometimes with different disciplines, we have different standards, we have different requirements. Even as a client or as a concessionaire, we sometimes may not be always correct. We may create some conflict in the tender. So that's why the technical challenges also from that technical requirement. The other side, the other hand about the technical challenge is about information, how to at this stage we have everything online. So how to secure the data and the information is another problem. The first point is the integration. So integration for the large scale project is quite critical because everybody can build their own model, but it is a standalone. So how to make the model work together, make them like integrated everything together, make everything visual, and could be the problem or the we normally call the crush, so could be visualized just by the integrated technique. Okay, the last one will be the delivery. So delivery at the moment we have different formats to delivery because we have different software, and the delivery format now is IFC as the international standard. And also the delivery challenges from the design to construction, the construction to operation are slightly different. Okay, because the information there are over the delivery procedures are like hand in hand. So we have to make sure that the information will be received completely and could be used for the next stage. Okay, for example, when we handed all the BIM models to the operator. So because normally the operator doesn't like, or doesn't need to see the big database, so many informations during the design stage, construction stage. So in this case, we have to make the model smaller, so extract all the information out, put in the database. So that means when the operator receives the model, is quite simple with the majority of the information. But if they want to see the detailed information, they just click on the members, and the data will be showing up from the database. So that's the different CAD stage. We have different functions or different shapes of the BIM model. Okay, this next one is about the international standard. At the moment, the standard for BIM is still at preliminary. This is my personal view. It's not like well developed stage. So the only one is this ISO 1965, right? Yeah, 6050. So that's the guideline for the BIM at the moment. So that's the structural. So we have summarized from our experiences. So the international standard, going downward, we have a data standard, and management standard is execution standard. So below the data standard, we have to make sure the data exchanged in some certain standard and the codification standard. That's like I said before, just now. So for the data exchanging standard, we have IFC, we have COBE, and for codification, we have a unit class 2015 or customized by the client. Okay. And management standard, we have information management standard. Like I said, it's ISO 196050. And the execution standard is modeling instruction and the BIM execution instruction and the BIM delivery standard. So that's we have certain standards and also some custom standard ROD. So okay, next one. Okay. So the standard, that's the the picture for the standard. We have this is the first the ISO 19650 is the first international standard in light on how to conduct the life cycle from the design to the asset management based on the BIM uses. Okay, next one. Okay, so that's another one to showing the execution. Okay, we have the unit class for the codification. Okay, for the codification. Yes, for the codification, and also ROD for the execution. Next one. Okay. Okay. Here's the BIM roadmap. So we had just list up the different the BIM uses from the different stages of the project. Okay. Totally is about 25 BIM uses through different BIM's project stages. And you can see the bar at the bottom, so with different colors. So this the development from ROD. So ROD means the precise level of the model, and with the details of the information attached to the model. So normally up to the end of the design stage, the level, the LOD should be reached to 350. And after that, during the construction, all the way through the construction, the model has to be developed by the construction activities, such as the quality inspection record, the qualities, materials, suppliers, maintenance, manuals, and some defect, NCRs. All this information will be added to this model, in addition to the design information. So when we reach to the O&M operation and maintenance, the model, the LOD will be reached to 500. So which the additional information from the testing commissioning. So that's the LOD development roadmap. So that's the BIM execution plan. So that's quite famous, were the mandatory document for every single project if we want to use the BIM technologies. So the BIM execution plan is quite critical for every single project. So it's including the BIM standards or resources, organizations, and also the codifications and the standard, and for the standard or manual for modeling, and the standard of the procedures for model reviews, quality controls, and also the information exchanges, and finally the delivery standards. So that's okay. That's the one in details in the right hand side. It's just some example for the appendix on the one BIM execution plans. So you can see that in details. So like I said, so we have quite just like a guidebook for every designers, engineers who knows how to place the BIM technologies into their daily works. So this one is about the delivery flow chart. So you can see, sorry about this, it's quite blurred. Okay. So from the model development, we created these procedures or the flow chart for the BIM delivery from the model development stage to the internal coordination stage, and next one will be like shared stage, and finally for the model review and the deliveries. So in different stage, we have different parties, different teams join the actions. So at the beginning, the BIM development stage, most designer, drafter, modeler is the majority of the resources, and the internal coordination, just like you said, the interdiscipline check and the coordinations and communications in this stage is quite important to make sure the individual models from different disciplines could be working together. They have no clashes, no interferences. For example, but sometimes during the design stage, one discipline could be changed by some reason, but these changes have to be notified to other disciplines. So they will take actions to do the harmonizations and the engineering check. If they have any problem to accommodate this change, they have to feed back their comments to the original parties who proposed this change. So this is not a one round communication. This is several rounds until they reach agreement with the changes. So after that, so we go to the share stage. That means all the models has to be shared to different parties, to the interventoria, to the client, to the third parties. So that's, I don't know, maybe I'm wrong. Yeah, okay. Okay, so in the share stage, so more parties got involved. The information can be checked by more parties. So finally, including in this stage, including the client review, and next one, the model review is organized by the client or by the concessionaire. They have to bring all the parties, not only the technical department, maybe construction and the procurement, and also the operation. So all the parties, or we call stakeholders, they have to know what the design looks like and what they have. Maybe they have some comments, otherwise at this stage. So going through all these stages, so I believe most of major problem or some errors would be identified and corrected. So we go to the delivery after that. Okay.
Could you show the last?
Sure.
comment,
Last
please?
one. Yeah, sure.
Okay. Take care of the photograph.
That one. The blocking the
Maybe
presentation. Maybe
I
we'll
think
go,
it's my next.
go to that laptop.
The next time. I'm sorry.
That's fine. That's fine. Sorry.
Right. That's
I take the time to drink this.
Cherry device. Yes. This cherry device.
The last one is.
This delivery.
Cherry device or revise it.
Model review. Is it? Which one? Which one is asking? Or you can use that.
Thank you very much.
¿Cuál estaba señalando? Disculpa.
No, eran las dos últimas.
Las últimas dos,
No había-
Model review.
Ah, sí. Revisión de los modelos y la última ya es como entrega.
delivery.
Okay, so this one, I believe everybody will maybe have questions about the quality controls on the BIM modeling, because different levels of modelers or drafters, engineer, they have different the capacities, experiences, so the design and the models would be varies. Okay, so in this case, we should formalize the quality controls in the BIM modeling. So from the different angles, we have self-inspections. That means when the modeler starting the model, create a model, the company or the project shall have a drafting manual or modeling manuals to standardize all these modeling behaviors. So from the IT development or the operation level, operation standard of the software. And when the modeler complete the modeling, they have to check a checklist with some items, different items of the basic requirements or on the standard. So that means the self-inspection or self-check. And the other one is a BIM standard verifications. So that's could be by the checker. So who's going to check the models when they receive they will receive the engineering information with the models, hand it over to the checker. The checker will check everything, make sure the design from the engineer and the model by the modeler, they're understand properly. Okay. And technical review is by the engineer, and also the clash detections would be by the tools inside the software. It will generate the clash report after running some features inside the software. And the other one is about the model parameters and the completeness checking. So that's also has to be by the checkers, and also the standard checking should be the final or the one of the work by the engineer and by the checkers. So through different peoples, so what models will be from the modeler, engineer, and to the checkers, to the discipline lead. So through those people's hands, so we believe that the quality of the BIM model will be maintained to the standard. Okay. Next one. Okay. So that's the BIM delivery criteria. So we have normally on the left hand, we have 2Ds drawing here, maps, so sketch here. The vertical is WBS. Okay. Normally we have the WBS for the one project. So all the models from the design stage, we focus on the WBS, the work breakdown structures. So normally we put the model down to the work package level. So what work package is for the location, discipline. So that means the structural is a discipline, right? But the work package could be down to the different locations, like one building or one segment of the road or the corridors. So that's the work packages. So one work package should have a single BIM model. Okay, that's one-to-one. It's easy to check and easy to do the like integrations. So we have WBS. Also, we have a BIM model breakdown. Just like I said, okay, we have one-to-one. That's little square. That means work package and from the WBS. So this work package generates a TIDP and work with the information center. Information center is come from the deliverable list. So for the large scale project, at the beginning, before doing any designs, we should plan for the deliverable list, which including everything, including the model, including the studies like the geotechnical, topographic, and also others, roads, surveys, whatever. So, and also the BIM models and drawings and calculations. So this includes overall whatever the designer will submit, will deliver to the concessionaire. Okay, so this part is I would like to talk about the collaboration in designs. So the common data element, we have now we like to talk about this CDE. This is the common data element. So this is quite useful in the collaborations in design stage from a different discipline, different design companies. Okay. Here is an example. That's the rail CDE we have done. So you can see we use the Aconex as the external port to for the deliveries, and we have DCC, which is a document control center, and some other disciplines. We have design, DMD, and the design department. So the information or the beam from the design department, sorry, in the center is the core of the CDE. We selected the SharePoint and the Microsoft BIM and the BIM 360 as the core of the CDE to take care of all the informations. You see the right hand side is the design group. Okay, we have different disciplines. So we have more than 2 design contractors and the suppliers. They are responsible for design and the modeling. You can see that all the information will be sent to these the core of the CDE, and they in this combination of the software, they are having the functionals in doing the storage of the information and some real-time communications like the Microsoft team, right? And manage the comments or the reviews and the history versions of the document by the BIM 360. So they take the different functions in managing the information among these 3 softwares. So make sure the information, if you want to ask somebody, in another company, questions whether why you consider like that, so you can through the Microsoft team to reach them. Okay, and all this communication record you can check in the future. So they maintain that, and the SharePoint is the online transferring the document, and BIM 360 is for reviews. Everybody come to give the authorizations. The people can review the models, put their comments on the models, and if you change the model, you can find the previous models anytime. They created the new version every day. So within these combinations, all the information could be exchanges. In this data was we call data centers. So that's the purpose of the CDE. So if without this, so everybody will go different way. So the information will be lost, sometimes got missed, and finally we cannot make sure all the information or the latest information attached to the models. Okay, that's the procedures for for the collaboration flow chart. So you can see the WFP, it means work in progress. Sometimes this offline. So because the people, when they work on their own laptop or computers, they would disconnect it to this cloud environment. So they make some changes when they feel they gonna internal checked, they will released, issued to this to the CDE. So when the model enter the CDE, they will run the share folders, whatever the reviews, technical reviews, run this circle, and finally they put in the public folders and back to the modeler. The modeler will be noticed after the procedure in the CDE. They got comments, and they will work again. And when they fix the problem, they release the model back to CDE. Okay, that's the standardizations of a data template. So this quite the details, because in order to schedule all kind of BIM data online, so we should formalize the data template. So instead of like everybody do different way, we put combine the attribute data, classification systems, standardized template, and the cloud-based database to realize the centralized management in the CDE. So all these templates or tools, procedures for these all for the CDE, how to run the CDE without any issues. The CDE is the very useful tools for the cooperation in the designs. That's video? No, not video. Okay, this is software. So everybody knows we have many software in engineering, drafting, modeling, and engineering. So here we have some matrix for the software, just like to standardize for one project, because different, if we have more than one designers, they may have their own software, or the software they're familiar, they're good at. So as a client concessionaire, we have to formalize which disciplines or the software per disciplines to minimize or avoid any problem when we want to get some design or models from different software like output and input. Next one. Okay, that's the cooperative design flow chart. So in this we have also that's example from the GIS, from the geologist information data, and they gradually develop to the federated models. So we have GIS data, we have models, structural models, architect models, and the mechanical equipment models. So this in different models, you can see they all send or have the data exchanges with the CDE. And finally, so we got the federated models. They bring all the model together, and after the CDE giving the feedback and request the feedback to to different disciplines. Yeah, so here we talk about the format. Maybe R3 2x3 are exported from the Revit and the Tekla. So Tekla is software for the structural designs, just and integrate and the platform and the collaboration. It's a video? No, there's no video. Okay, yeah, you can see that Revit and the Tekla. We have a network and but we have structurals here. Yeah, next one. This is about the design, BIM design management. We have now we have a different software or platform to handle the project management or the BIM management. So you can see this. For example, Relastics is for the interface. The BIM track is for the for what? Clashes. Yes. And SharePoint and something like that. So we have more tools to handle this, the BIM management. Okay, here's another example for marking different status of the BIM model by colors, by the color code. We can see the BIM model, the left and bottom, this with different colors, and the tables showing the meaning of the colors. You have the identifiers, and in developing in red, coordination in orange, and frozen I think in white, and the references in yellow, delivered in green, and the 2D instructions in purple. So that's different stages, different status with different color codes. So that's because for the large scale, every multidisciplines, sometimes it's hard to find out the status of the model, which model is released, which models and their coordinations. So this color code may help too much to all the designer engineers knows the status of the models. All right, so that's the flow chart. We started from the work in place models and to the shared to the models to share the model change controls. I mean, here we use change control means the coordination. There's a change request by one disciplines. This request may have impact to multi-disciplines. So this kind of a change, like internal change. And finally, we after this round and round check and request and the incorporations, so we reached the level of baseline, and we can release that as the stages models. For example, in Colombia, this is quite common in 60%, 90%. Okay. All right. So this also example for the BIM uses in the interface management. So normally, like traditionally, we use the matrix for the interface management. So like showing the right hand the table, we have different disciplines, and we marked in the matrix who's the interface owner, who's the party to support this interface, provide input or the reviews. Okay, so the BIM, we use the BIM technologies can put something in visualize. So if the member or some buildings, there's some interface to open, they will be showing different colors, highlights to the reviewers. This interface still open. So when you click on that member, you will see the information of the interface. So who's the owner, who's taking it, whose actions is still pending or delayed outstandings. So we'll take actions through the BIM model. Okay, so from this part, we talk about construction application. This quite, I don't know what is quite widely used in Colombia, or it's quite widely used in China. Because we have sometimes the area of the construction side field is quite large. So we normally use the monitoring and some sensors to control the site. Yes. This is new technologies just come from the United States. Well, yeah. So when the camera fixed on the top of the helmet, when the people walking, and the camera will catch all the informations and can transfer to the beam centers. They back and they can come up with the rail or the simuls, the pictures and in 3D. All right, so this one is about is for the simulation of the construction. With the design models, the contractor could put their idea or in the construction from the like sequences and the machineries, how to place their machineries, and how the building that we build start from, and layer by layer or floor by floor. And so this is useful tools for the contractor to practice their proposals before put in the real planning. So also, this concept is quite popular now. We call the build twins. So that means we built something in the BIM model. We simulate the structural, how the structure built, and finally we built it. So this these two like a twins. Okay, when you want to know this, the information of some particles or element in the building, you just click on that in the digital models. So they're identical. There's like a twins, one in the real world, the other one in the digital world. Okay, that's for the construction. So we have the planning. You can see this these colorful pictures, and this in 2D. It's showing the planning stage with the resources allocations for the especially for the linear project, like highways, like some metros, whatever. So this linear project. So that's from the planning map. So gradually with the GIS, you can see the downward is the GIS, right? The GIS system. So we put them together, okay? With a planning map and the GIS map, we plan it together. We can stimulate the progress or the future visuals for the project. Okay, so now we call the BIM plus GIS. Okay, this part is about the operation orientated digital deliveries. So like I said in the beginning, the design has to consider the operator's demand at the beginning. So in project lifecycle, the BIM mainline task is the following: the cooperation, the integration, delivery, whatever the delivery in the O&M stage is useful. So we consider the CapEx and OpEx as a concessionaire. BIM is sometimes a very useful tool to tell us the time and the cost quantities, and also the information attached could help the operator understand the OpEx during the operation stage. So here another example about how to put the BIM use in the operation stage. We call the BIM plus MMS platform. MMS is like a property management platform for the operator. At the moment, as I know in the world is still at the beginning, quite beginning. A lot of the companies, operators, they spend a lot of money on the studies, how to make this MMS platform useful and intelligent in maintenance to reduce maintenance cost, especially the management cost, and also reduce the risk in an accident by the human beings judgment. So with the BIM, will provide the large or comprehensive data from the beginning. We call assets. Asset means everything. So it's permanent structures and the properties for the project. The operator has to manage everything. So they would like to know every tiny articles in somewhere, how to replace them, when they have to replace that, and where's the suppliers, how to get the suppliers information, how to order the parts, and how long the part could be here. And so this kind of information from the BIM. So that's why the combination or the cooperation between the BIM and the MMS is quite useful, because sometimes the operator have their own operation manuals. They have their own schedules for the repair and maintenance. So in this case, the information is quite important, because sometimes you want to do something, but you don't know where the part come from. What kind of specifications of this part. So that's why the BIM is like the fundamental or the database for the MMS. Okay. Also, they can provide some space management. Like you wanna replace something, you have the BIM model for the building. The operator will know what kind of machines is suitable or the tools are suitable to do this job. Okay, that's integration of the BIM and MMS management platform. So that's an example. So for the operation of a building, so we have CCTV and some like toll or some control system, telecom, radio comm system. So we decentralize to the SCS. SCS means the central monitoring system. So, and with this, all those information will send to this center, and laterly they send to MMS. And the MMS, we have, if they have request from the wording of the ICSS, but they want to know the information, so they can automatically take the information from the BIM database. So that's the work style from the MMS and the BIM platforms. Okay, so that's the management platform looks like, but this one is still under, I think it's under studies. So I don't see it's quite a developed product. So that's the future. Yeah. So, but the module for the platform is the basic parameters, ONMs, parameter access management, and data and information. Yeah. So that's this is the asset center database. So you can see this, the different, we have the codification system, like 2 clouded bases, collaboration platform, 1 business management platform, 1 code-free integration platform, and the relational database, and connected with BIM and GIS software. So all this information, assets, should be defined during the design stage. What is asset for the operator? Okay, is a big machines or a little school? So they have to divide by different operator. They have different focus. Maybe some operator just focus on the big properties, but someone they would be really really care about the cost, that they will come down to the very simple, very tiny particles. So this depends. Okay. Also, that's asset database. It's a deliverable. It's come from the deliverable list, TIDP and MIDP. Is have a different stages. So based on the data model separations and the second development, for example, the Navisworks and the Revit, the BIM model attributes could be uploaded into the cloud through the data center. So this is quite the details. If you guys are interested, we can talk about it after this. Okay, so this kind of sketches 3D for systems model. So you can see that, and if they need some information, you can just facility and equipment information search on the right top. You click on that, the information of the equipment is coming out. Okay, and the system and the O&M data monitoring. So they have indicators attached to that. If you open that, you can see the status with the monitors and equipment operation status evaluation. So that's different. That's multi functions in this status evaluations, but have to be set up by the operators. Okay, that's almost all. So sorry, some Chinese. This for share some pictures for the China Harbor's project with the BIM model, BIM technologies. So this one, you guys may be familiar with that, is the Panama Forest for Bridges. So we now that the project has been suspended, but now I heard they're gonna coming maybe in the negotiation stage, maybe restart pretty soon. This project we had planned with the designers by the 100% BIM uses and the forwarding design procedures. Okay, and the other one is quite long cross sea bridges. It's a Hong Kong, Zhuhai, Macau. Is about I couldn't remember the length of the bridges, but the picture showing is that this one of the starting point of this bridge is in Macau. Yeah, all these buildings, facilities are designed in the BIM element. Okay, this project won a lot of awards in the BIM. So this one was my project in Sri Lanka, Colombo, this port city. So it's under development. So the BIM is starting use for this project. This is a city with multi functions. It's living, business, entertainment. So the BIM has to be used for this kind of large scale project. Okay, the last one is about the Hong Kong waste treatment plant. So you see that this project is under construction now. So they are the BIM applications was well used in this project. So they threw the 3D and the 4Ds, and so same LOD to us. It's a 500 at the end of the constructions. All right, so we reached the final page about the value. Okay, So based on the experiences I have in the China Harbor, we had a lot of a project with the BIM technologies and the BIM uses. We think these techniques really help on the engineering. It's not only for design and for the construction methodologies, avoid the risk, avoid reprocessing and the cost controls, time controls. So if we widely use that, we put these technologies with other technologies, with integrations. So we'll make more value to the project from the time, schedule, and the technical compliance. Okay, so that's about my presentation today. So I believe this today is too short. Yes, almost 1 hour. Okay, so it's too short. Just the opening to brave the BIM technologies, and from my personal view, the BIM technology would be keep continuing developed with maybe AI, with other technologies. So they'll be the fundamental for the future development. So I'm looking forward to meet you guys again, so we can have the exchanges, the opportunities. Thank you, Harold. Thank you so much.
Bueno, Engineering David, thank you for your time, and thank you for your preparation, and thank you for your excellent presentation.
Ah, gracias, gracias.
Muchas gracias.
Muchas gracias.
Quiero aprovechar entonces un espacio de preguntas, pero yo quiero recordarle al auditorio presente y virtual que en Colombia la metodología BIM se ha venido empleando, yo creo que por allá desde el año 2000 para infraestructura vertical. Y muy recientemente, y creo que este es el primer ejercicio formal de retarnos a emplear esta metodología en infraestructura lineal. Como lo hemos podido ver, esta metodología BIM tiene unas interesantes aplicaciones porque integra a lo largo de todo el ciclo de un proyecto, desde que lo planeo, diseño, construyo, opero y mantengo. Y muy importante lo último, gestión de activos. Yo puedo, después de que construya, me quedo 20, 25 años, construyo y tengo que gestionar mi activo, maximizar mi activo, minimizar los costos del activo, y para ello, como nos explicó el ingeniero David, hay que hacer monitoreo y todo está integrado. Entonces, ¿cuál es el reto? Yo tengo two questions.
Sure.
Two questions for you.
Okay. Thank you.
Excuse me. Si no estoy mal, el gobierno pasado sacó un decreto donde dice, a partir del año 2026, todos los proyectos de infraestructura que se hagan en Colombia, del orden nacional, departamental y municipal, tienen que contar con metodología BIM. Entonces, muchachos nuevos, presentes y por allá en virtual, tenemos que prepararnos para hacer la tarea. Y las entidades viales estatales del orden nacional, departamental y municipal también tienen que prepararse. Estamos aproximadamente a 4 meses de que termine el 2022, empieza el 2023 y el 2026 se acerca. Es un gran reto. The first question, please. ¿Cuál es el reto más importante que hay que tener en cuenta para arrancar a hacer el BIM de manera exitosa? First question.
What do you think is the most challenge in the BIM in order to start in this kind of construction? Maybe it would be in the project, would be the most challenge that you consider.
All right, I think this is the big questions because like I said, we have 5 challenges. Now we ask which one is the most difficult. Okay, I would say through several projects with the BIM, I think sometimes the company or the designers, if they're willing to implement the designs with the BIM. I had some experience in some companies. There at the beginning, they don't like that. They don't like the BIM, because the BIM, they have to throw the 3D models, but usually we just produce 2D drawings by some standards, like some imaginations, pictures in our mind, right? But maybe at that time is fine, okay? But at the moment, the project got more and more complicated, okay? Including more and more disciplines. So our imagination sometimes doesn't work. So we have to rely on this kind of a computer or some modeling 3D techniques to get it visualized. So instead of by our brains. So this kind of changes is quite hard sometimes, right? If if this kind of a standard or rules or principles are built in the engineering field industries, I believe in the long run you will see the benefit. You will see the design would be perfect from the beginning. So when the design is born is a very strong baby, right? So you won't be take him to the hospital or whatever. So you don't need to reprocess some things, because in the past without the BIM, most of the times we'll face the clashes on site during the constructions without any advance notice. Okay, we didn't aware of that. So everybody follow the drawing, lay the pipe, build the buildings. But at the end, when the two guys made together, they will have gaps or they conflict to each other's. At that moment, the engineer has to come out to fix the problem, but it's too late, right? If we have this kind of visualized simulations for the construction, so we can have that observe or find out these problems in really early stage, fix the problem. So construction would be without any stop. Okay. I think so. I think we have to change our mind if we with this new techniques. Yeah. Maybe at the beginning is not quite easy. Yeah.
Thank you.
Yeah.
And the second question for me is, antes de BIM, ¿cómo hacemos el control de cambios de un proyecto? Una tortura. Y ahora con BIM, pues se nota que es más fácil hacerlo. ¿Cuál es su percepción? Please.
About if BIM exists, the control change was really difficult. And now with BIM methodology, how do you think it is going?
For the what? For the construction?
Exactly.
Okay. So this also we have some experiences or successful projects in China with this. So we call the intelligent construction site. We have a lot of now they're making a standard, I think. So we have all the things controls for the materials controls. When the material come into the site, they will have the record at the entrance and going through, give the tag, maybe QR code, and going through all the person to person to the stocking pile, stockpiling. So they manage all by the computer, by the systems, or this material and the machineries. We put sensors on the material on the machines. Okay, they monitor the status operation conditions of the machines, and also they can locate it all the time where the machine is, right? And where the movement, and the other one is the labor. Okay, we have the counting, we have the sensor on the labors, the vest or the helmet. When they move in, so we count it. So just in case we know how many people working in the construction site. Okay, this is quite simple, like functions for this kind of a construction controls, and also we have this we have the crane, the tower cranes for the building. So we have all the sensors on these machines. When on the like severe weather conditions, so all the monitoring data could be sent to the control centers. By the analysis, we can like manage the operation of these cranes. Maybe we have stop, or we do some anchorage for this. So everything is by the data. If we use the BIM technologies, right? So all the BIM technology technique is like a foundation. So our like intelligent construction sites is built up from there. So they have all these data informations for the site, for the designs. So the easier to add it on some features by different instrument or whatever. So we can like the video we just showing. So the guy with a camera, they can get all the information surround. Okay, and all this information are a little bit smart. So they transfer to the center. They know everything about the site, about the progress, about the qualities, the materials, and also the health and safeties. Okay, so this the use, but is underdeveloped. Right? Yeah. We're trying to something here.
Thank you very much.
Yeah.
¿Alguno de ustedes tiene alguna pregunta o por modo virtual? Entonces, por favor, levanten la mano y el ingeniero Julio, adelante. No en español, porque así
El BIM, primero que todo, necesita alta tecnología, ¿no? Pero estamos llegando al cúmulo de la tecnología y ese es su éxito, ¿no? Porque antes había planner, ¿ah? Haber aprendido primavera. Sí, y primavera, y rollo claro. La corrección en uno de estos schedules puede ser en la entrega o puede ser en la fabricación o algo que es muy grave cuando la financiación no llega a tiempo. Eso es automático, él integra inmediatamente todo eso.
I'm sorry, can you repeat the last?
Sorry.
Well,
No problem. Spanish is fine.
¿En español otra vez?
Discúlpame.
Bueno, el BIM es el cúmulo de la alta tecnología. Y para aplicarlo se necesita todos estos desarrollos tecnológicos que hemos tenido, ¿no? Desde la época en que hicieron el Nautilus, el Planner, el Project Management y el Aurora, el Primavera, todo esto. Entonces, hay el momento de los errores o las correcciones, llamamos. Correcciones desde el punto inclusive de rendimiento humano, correcciones de transporte, como el que acaba de pasar el año pasado, ¿no? Inclusive por los containers, correcciones por retrasos financieros, por muchas cosas. El BIM, como integra todo eso, lo lleva a un control center donde analiza y reajusta el programa.
No, lo que sucede acá es que nosotros manejamos un modelo que se llama as-built, es decir, cómo se construye. O sea, es como una maqueta de lo que se está literalmente construyendo. Entonces, en estos casos, cuando estamos en la construcción y existe una modificación, lo que tú comentas, tuvo que cambiar esta cantidad, etcétera, el modelo también se actualiza y automáticamente vuelven a sacar como las cantidades de manera automática, que es lo único que uno tiene que hacer, actualizar el modelo, y del modelo se extrae toda la información.
Perdón, pero es que no estoy hablando de la construcción, sino del manejo, porque el BIM es precisamente para manejar. No, es integral.
Tal cual, o sea, tal cual, ese procedimiento que te comento,
todos esos errores
aplican todo el proceso. Entonces, si uno observa que existe un error
o imprevisto, llamémoslo, que no sea
digámosle un imprevisto, porque el BIM también nos permite ver colisiones antes de la construcción. Entonces, no sé, hubo una colisión y es necesario modificar ese diseño porque no funciona. Entonces, desde el diseño se generan mesas de coordinación para efectuar qué cambio se debe realizar. El cambio se maneja de manera de diseño y después se aprueba. Se dan soluciones, ¿sí? Y después los modelos se actualizan. Entonces funciona así, es un flujo de trabajo en cuanto a implementar el diseño con base también en los modelos. No sé si respondo tu pregunta.
¿Ese centro de control tecnológico va a estar aquí en Colombia o en la obra?
Eso se maneja desde el inicio, o sea, desde el inicio, desde el diseño, aplica para la construcción, y finalmente tenemos otro estado que es como operación y mantenimiento, que hace referencia a como teníamos un gabinete contra incendios y necesito buscar la referencia. Entonces, en ese estado se llama operación y mantenimiento.
Sí, esto de los 20 años de operación y mantenimiento, pues además es porque hay que cuidar la concesión.
Activo, gestión de activos, gestión de activos.
O sea, lo ideal es siempre centralizar la información.
Thank you very much. ¿Alguna pregunta a los asistentes o por allá por el modo virtual? No sé cómo se da uno cuenta si hay alguna pregunta. Mientras tanto, aquí hay otra pregunta, por favor, levantó la mano, adelante.
That doesn't matter.
No, don't worry, because tenemos traducción.
No, para algún proyecto del que ha hablado el ingeniero o este mismo, ¿qué es algo que él hubiera hecho distinto desde el principio, el tema con lo que está relacionado con el BIM?
Cambiar un criterio de diseño.
Empezó con su modelo de interpretación de cambio, entonces, ¿cómo lo hizo?
I mean, for example,
Entonces, la metodología
to
Sí.
have a project, okay? And then
Reconocer que
visualize that,
Casi todos.
la planeación.
Bueno,
based
listo.
on
Listo, ya tenemos.
in the beginning, it would be better. According to the model.
Exactamente. No,
Okay, so we want to know what's the BIM change.
What have you been, like, what's something that you would have changed in the beginning
Okay.
so that it worked easily, seamless throughout the process?
Para los virtuales.
Cairo.
No, estaba preguntando,
Okay.
estaba preguntando qué cosa habría hecho diferente en el tema de la metodología BIM desde el inicio del proyecto.
Yeah. So also at the beginning, like I said, the BIM execution plan. Okay. We started from the BIM execution plan. When we got to start the project, we started collecting the demands, the requests, the technical, and the software from the different disciplines, different company, different parties. So that's the preparation stage for the BIM execution plan. But during the implementation stage, okay, we may have some certain situation is out of this plans. Okay, so when we have some experiences in fixing this problem, so by certain period we have to change or improve develops the execution plans. So that's the dynamic process. Okay, definitely. So nobody can plan perfectly at the beginning. So I think we have to learn from this every problem and make the execution plan at the end. So to complete the project. Okay. Yeah. But I don't know whether it answered the question.
Yes.
Okay,
yes,
thanks. Yeah.
It's like prepare the BIM execution plan and be aware that it's going to change, but
Of course, yeah.
yeah. No, que sí, estoy de acuerdo con lo que decía, que preparar el PEP para teniendo la conciencia de que va a cambiar, pero pues siempre siendo muy detallistas al principio, ¿no? Para que sea una buena planeación. Eso es lo que más tiene que trabajar uno para que no se descarrile eso.
No, y adicional que todas las obras son diferentes, entonces en cada marcha uno aprende de esos errores para complementar los siguientes.
Okay. Finish. Thank you very much. Thank you very much.
So I would say if everybody want to talk about more about BIM, just Harold knows me, so to find me, okay, we'll have another chance to discuss. Yes, it could be very large topics. We can discuss every single topics in details. Okay, we really like to see more and more resources from Bogota, from Colombia, because I have arrived in Bogota 2019. I have visited most of the famous university in Bogota. I have asked the questions to the professors whether we can get more BIM engineers, modelers from the university. That will be the future of the engineering in Colombia. So we would like to help if you guys want.
Thank you very much. Entonces, para finalizar, tenemos varias preguntas, modalidad virtual, pero las estamos examinando y son del proyecto Metro, entonces nosotros las vamos a revisar y por intermedio de aquí de Mauricio, nuestro enlace con tal vez con Elizabeth, se las enviamos bien organizadas para que por favor ustedes, si consideran que deben contestarlas, pues nos ayuden a darle respuesta. Entonces, cualquier tema al correo de Mauricio Hernández ACIEM, nosotros las examinamos, se las enviamos y muchas gracias. Y finalmente, en un par de semanas los invitamos a tomar café aquí, a un conversatorio de otros temas comunes que nos interesan conocer de la ingeniería china y que ustedes conozcan de la ingeniería colombiana. Thank you very much. Good. Happy night.
Nice, happy. Very good, very good.
Thank you very much.
Thank you very much.
Thank you very
David, thank you very much.
Thank you, Harold. Thank you very much.
Bueno, agradecemos a nuestros asistentes de modo virtual por su compañía y su asistencia a esta conferencia.
Entonces, el ingeniero Espejo nos va a explicar el PIB. You will be our teacher. Yeah.
This is from the technical school, Central Machine. This is.
Okay, perfect. Okay.